Hi everyone, welcome to this episode of Keipert Labs. In today's video we're going to be investigating the different types of chemical reactions. So firstly we're going to remind ourselves what we mean by a chemical reaction, and then we're going to take time to go through these 6 different types of chemical reactions. So synthesis, decomposition, combustion, precipitation, acid-base, also known as neutralisation, and acid and carbonate. So what is a chemical reaction? A chemical reaction involves the rearrangement of atoms to form one or more new substances. So we're taking atoms that were connected in one way and then we're reconnecting them to make in a different way to make a new substance. Okay, so it involves the breaking and making of bonds. So breaking existing bonds and forming new ones. Okay, so we're breaking the bonds between these hydrogens and these chlorines in hydrogen and chlorine gases to form HCl, or hydrogen chloride, as a new substance. Okay, so this is a chemical change or chemical reaction. So let's firstly look at synthesis reactions, sometimes called combination reactions. Synthesis reactions involve simpler reactants combining or joining together to form fewer or more complex product molecules. Okay, so we're taking calcium atoms and oxygen atoms and joining them together to synthesize or create calcium oxide, CaO. Okay, now we have, so depending on exactly the situation, that we might be taking elements and joining them to make compounds. We might be taking simpler compounds and joining them together to make more complex ones. Okay, so we've got two example of each of those here. We've got hydrogen and oxygen gases forming water, synthesizing water. We also have compounds, simpler compounds joining to make more complex compounds and fewer more complex products. So carbon dioxide and water combining to form glucose and oxygen in photosynthesis. Okay, so the general reaction for that is A plus B forming AB. Separate, simpler things joining to form fewer, more complex things. The opposite of this is what we call a decomposition reaction. Decomposing, this idea of breaking things down. We're having a more complex reactant, we're breaking it down or decomposing it into simpler products. It may be elements, it may be compounds, it may be a mixture or combination of those two things. Okay, so we're taking this copper chloride and we're decomposing it into copper metal and chlorine gas. Okay, so like decomposing hydrogen peroxide to form water and oxygen. Decomposing copper carbonate to form copper oxide and carbon dioxide gas. So the general reaction, we would say AB breaking down to form A plus B. So the reverse of what we've just looked at. Now let's look at combustion reactions. The sort of thing that helps to keep us warm, when it's in winter, helps us to cook our food. Is this type of chemical reaction. So combustion involves the burning of a hydrocarbon compound in the presence of oxygen gas. So hydrocarbon is a compound that contains predominantly carbon and hydrogen atoms. Okay, so we're not talking about ionic compounds, we're not talking about other kind of combinations of elements, we're focusing on this type of thing, combustion generally speaking. And certainly the burning in the presence of oxygen is kind of a fundamental aspect. Sometimes we talk about combustion of other things like magnesium, where there's no carbon and hydrogen, but it still fits this profile because we're burning it in the presence of oxygen. With hydrocarbons that we produce carbon dioxide and water. So this one here we've got methane reacting with oxygen to form carbon dioxide and 2 water molecules. So we've conserved all of the atoms there, but we've formed these 2 types of products. Okay, so this kind of reaction is what powers, we use an LPG to power a barbecue. It involves octane in a petrol engine to power the engine, or diesel, the same sort of way. All of them are based around this combustion process. Now, depending if we have a little less oxygen, we might end up with carbon monoxide or soot as one of our products over here, but generally speaking, this is the sort of reaction that we see. Precipitation reactions. So we've got some examples here, like copper sulfate combining with sodium hydroxide solution, and we're forming a precipitate, a solid or a cloudy new product that's insoluble. Precipitation reactions are also known as double replacement reactions. Okay, so, and I'll show you why in a moment. We're forming 2 new ionic compounds. So we're combining 2 ionic compounds and we're forming 2 new ones, one of which is an insoluble solid, that is a precipitate. It's the cloudy appearance that develops. Okay, so this reaction that we have here on the left, copper sulfate plus sodium hydroxide, gives us insoluble copper hydroxide, and then the rest of the solution is sodium sulfate. Okay, so the copper and it's like the copper and the sodium have swapped places, or you could think about it that the sulfate and the hydroxide have swapped places. The effect is the same to form two new compounds, one of which is insoluble. Okay, likewise, then looking at lead nitrate and potassium iodide, that is an I, not an L, just by the way, forming insoluble lead iodide and soluble potassium nitrate. Okay, so generally speaking, the general kind of reaction, AC plus BD forms AD plus BC. So I've color-coded them so you can see that the C and D, or the A and B, depending on how you want to look at it, have swapped partners to make two new substances, one of which is solid. Now, we can use a lot of, there are rules that we can use to help us identify which will be the precipitate. It's not something that you can just kind of look at and think, oh yeah, that's about right. We have determined what kinds of compounds are soluble and insoluble. We call those solubility rules, but we're not going through that at the moment. Okay, so second last one, acid-base or neutralisation reactions. Okay, so for example, combining hydrochloric acid and sodium hydroxide. So acid plus base gives sodium chloride and water. Nitric acid plus potassium hydroxide gives us potassium nitrate and water. Sulfuric acid plus copper oxide gives us copper sulfate and water. So we're seeing that we have a fairly general kind of pattern here. Acid plus base gives us salt, an ionic compound, and water. Okay, now salt doesn't, in chemistry terms, remember, that doesn't refer just to sodium chloride, which is what we eat, but it refers to an ionic compound like this. So you can see that we've got the sodium and the chlorine from here joining to make our product. Nitrate and potassium over here, sulfate and copper over here, and the remainders are forming the water. Okay, so in terms of actually the ions that are really doing the work here, it's actually the hydrogen and the hydroxide that are joining to make a new thing. So the others we call spectator ions. But so we're taking an acid and a base and joining them together to make something that is neutral. Hence the name neutralisation reactions. And then our last one, acid and a carbonate reaction. Okay, so just like we might have hydrochloric acid plus sodium carbonate, gives us sodium chloride, carbon dioxide, and water. Classic vinegar and bicarb. Acetic vinegar is acetic acid in water, sodium bicarbonate or sodium hydrogen carbonate, giving us sodium acetate, carbon dioxide, and water. So it's very similar to the reactions we've just seen, but with the added combination of the carbon dioxide gas. You know, that's the whole point of doing the vinegar and bicarb kind of reaction, that we get that fizzing, we get that bubbling. And so, it's due to the fact that there are carbon and oxygen atoms in the carbonate compound that we're reacting. That's where that carbon dioxide comes from. Okay, so this is the general reaction that we have. Acid plus carbonate, so something that's got these carbonates in it, goes to salt, carbon dioxide gas, and water. Okay, so we've reminded ourselves about what a chemical reaction is, the rearrangement of atoms to form new substances, breaking and making bonds. And we've talked about these 6 different types of chemical reactions. So we've gone through some examples, talked about what they mean, as well as then some general information on their equation. Alright, don't forget to like and subscribe. Thanks very much for watching. Bye for now.